September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob.
When C2025 V1 first appeared on astronomers' radar, it was dismissed as another long-period comet making a routine swing through the inner solar system. Nothing unusual, nothing alarming, nothing that broke models. But that changed the moment someone compared its behavior with 3IATLAS. The interstellar object that survived a solar past no natural body should have endured. Stay with me through the last minute of this video, because the conclusion raises a question no single researcher can answer alone. When you see the final finding, drop your insight in the comments. I'm genuinely curious where you stand. What began as a simple orbital comparison turned into something far more unsettling. The motions didn't match, but the timing did. The composition didn't align, yet the anomalies overlapped. Two objects, unrelated by origin, began displaying features that seemed to rhyme, like two verses in a cosmic poem written across millions of years of space. The question that now echoes across research teams quietly sharing notes behind the scenes is simple but explosive. Are C2025 V1 and 3IATLAS connected in some hidden way? Maybe not physically, but through behavior, origin hints, or something deeper that we've never seen from any visitors before. To understand why this idea is gaining traction, we have to look at both objects separately before seeing how they converge. C2025 V1 is technically a hyperactive comet. It began outgassing earlier and more intensely than its models predicted, almost as if it woke up prematurely. Comets normally begin outgassing gradually as they heat, but V1 behaved like it had volatile materials sitting directly beneath the surface. Too close, too reactive, too exposed. This alone wasn't enough to raise alarm bells. Hyperactivity isn't rare. But what turned heads was the precision of the jets and how the comet's rotation did not destabilize under the asymmetric force. Instead, V1 maintained rotational balance, almost as if something was counter-stabilizing it. That behavior is extremely strange. Natural comets wobble, tumble, drift, and sometimes break under uneven jet pressure. But V1's spin seemed almost engineered, not by intention, but by some internal structural order scientists weren't expecting. Then came the brightness curve. Over the weeks of observation, V1 brightened in a way that didn't match its dust predictions. It was too clean, too smooth, like a reflector instead of a scatterer. Some researchers whispered that this pattern resembled one of the speculative models proposed earlier for 3IATLAS, suggesting a surface with unusual heat distribution. Meanwhile, 3IATLAS was producing mysteries of its own. It survived perihelion. It formed a ghost shell. It developed a precise anti-tail. It refused to break apart. And now, when the data sets were laid side by side, a bizarre similarity emerged. The dust-size distribution of both objects appeared unusually narrow. None of this proves anything. But narrow dust distributions are rare because natural comets shed particles across a wide spectrum. The fact that C2025 V1 and 3IATLAS show similar ranges, despite origins separated by interstellar distance, is at the very least a puzzle. Was this deliberate? Almost certainly not. Was it coincidence? Possibly. Was it a sign of similar formation environments? Maybe. Or does it point to deeper cosmic processes shaping objects in a way we barely understand? That question gained momentum when researchers noticed a second pattern. Both objects exhibit extreme resilience to solar radiation pressure. Comets normally show subtle deviations from predicted trajectories because their dust tails react to sunlight. But both 3IATLAS and V1 maintain tighter paths than expected. In simple terms, they didn't get pushed around easily. 3IATLAS's stability made sense only if the object had unusual density or structure. But V1, a comet showing similar resistance? That makes no sense under normal physics. It should drift more than it does. But it doesn't. Something about it holds form. Then, something even more unexpected happened. C2025 V1 exhibited a temporary halo flare, a short-lived expansion of a faint glow around the nucleus, extremely reminiscent of the early-stage ghost shell seen later around 3IATLAS. V1's halo flare faded quickly, while Atlas's ghost shell strengthened, but the initial shape, the first few hours of its emergence, was virtually identical. Two cosmic visitors, two independent objects, two halos emerging under different conditions, yet visually and behaviorally similar. Coincidence? Possibly. But astronomers are beginning to question those coincidences. Some believe the similarities could be signs of a cosmic archetype, objects shaped not by their origin, but by the environment they pass through. For example, high-energy astrophysical environments like shock waves, magnetized clouds, or radiation fields could imprint certain properties on objects long before we detect them. If C2025 V1 passed through such a region millions of years ago, it could share characteristics with 3IATLAS without being physically connected. Others think these similarities could reflect unusual core materials, rare but naturally occurring compounds that behave differently under heat. If both bodies contain traces of such material, their halo behavior might be related. But there's a subset of scientists entertaining a more radical possibility, quietly, cautiously, behind closed doors. They propose that both objects may originate from stellar systems with similar formation histories, meaning they could share structural traits, even if separated by vast distances. This idea grows from a simple observation. Both objects behave like they were shaped under far stronger pressures than anything in our solar system. Their resilience suggests internal bonding we don't typically see in icy bodies. If we assume 3IATLAS originated from a system with particularly intense formation pressures, say, near a high-mass star or in a region saturated with stellar winds, then similar properties appearing in C2025 V1 could indicate it, too, came from such an environment. This doesn't mean the objects are related, but it could mean they're cousins, shaped by the same type of cosmic furnace. Then there's the orbital timing. The arrival windows of C2025 V1 and 3IATLAS overlap by months in astronomical terms. Normally, this means nothing. Comets enter on their own schedules. Interstellar objects enter on theirs. But some researchers noticed something compelling. The specific angle of approach for both objects, relative to Earth's orbital position, allows ground-based telescopes to capture similar types of observations from similar angles. This is important because certain anomalies only appear under specific viewing geometries. The ghost shell of 3IATLAS, for example, was only fully recognized once light scattering aligned perfectly with telescope positioning. The same applies to the strange brightness patterns of C2025 V1. In an odd twist, both objects became diagnostically visible at the same time of year under similar Earth-Sun angles. That coincidence is making some people wonder if we're not seeing the universe behaving strangely, but just seeing it more clearly than ever before. Then there's the antitail question. C2025 V1 has not shown an antitail like Atlas's dramatic one. But when astronomers analyzed deep stack images, they found a faint linear structure trailing V1, not pointing toward the sun, but not pointing away either. It sits at an angle that suggests heavy materials are drifting in a pattern that doesn't match basic dust mechanics. This faint structure disappeared, then reappeared, then shifted. It's unstable, but not random. And here's where things get interesting. If V1's faint structure is a precursor to a proper antitail, it could mean the comet is entering a phase that 3IATLAS already passed. Or V1 may be responding to solar radiation in a similar way. Only its composition isn't strong enough to maintain the structure long-term, creating a messy analog of Atlas's precise antitail. Again, not proof, but not dismissible either. As astronomers overlay the behavior of these two objects, three big coincidences stand out. Both objects maintain stability and resist solar drift beyond expectations. Both show structured halo formations uncommon in natural bodies. Both display narrow dust distributions and unusual light scattering patterns. These are the kinds of similarities that create debates. Some scientists are asking whether we're witnessing a new class of ultra-stable, interstellar, and long-period objects. Others think the similarities reflect material science we don't yet understand, objects shaped under pressures, temperatures, or cosmic events far beyond our solar system. But there's also the chance that we are simply observing more deeply than ever before. Our telescopes are better. Our data processing is sharper. Our interest is higher because 3IATLAS forced us to pay attention. If C2025 V1 had appeared 5 years ago, before Oumuamua, before Borisov, before Atlas, would anyone have noticed its anomalies? Would anyone have compared its light curve to an interstellar visitor? Probably not. Maybe these objects were always strange. Maybe we just never looked hard enough. But the more data researchers accumulate, the harder it becomes to dismiss the parallels as random. A few scientists have even suggested, very carefully, that C2025 V1's behavior could act as a comparative model, helping decode what's happening inside 3IATLAS. If V1 is a weakened natural version and Atlas is an amplified interstellar variant, then studying both side by side might reveal universal physical processes at work in the galaxy. This is the real heart of the connection question. Not that they came from the same place, not that one caused the other, but that both may represent a broader category of cosmic bodies with hidden internal physics we don't yet understand. A connection not of origin, but of nature. And as more telescopes focus on V1 and more anomalies emerge from Atlas, the idea grows stronger that we may be witnessing a cosmic pattern manifesting in different ways across different objects. Perhaps the universe is trying to teach us something. And maybe these two visitors, one interstellar, one cometary, are the key. Do you think C2025 V1 and 3IATLAS are connected through formation, behavior, or something deeper? Could both objects be examples of a new class of ultra-stable cosmic bodies? Are we witnessing a cosmic pattern we never recognized before? Answer in the comments. And don't forget to like and subscribe for more deep space mysteries.